Hello, welcome to Tech Talk with Steve, episode 20, Powering Smart Buildings and Assuring Infrastructure Readiness. We talk a lot at AEM about assuring infrastructure readiness. We talk a lot about how to test what's in the building, how to make sure that your cable plant is ready to support things like PoE and the Internet of Things. But what goes on behind that? What's installed? What is in the background that we're actually testing? So today we're going to have a very special guest. I'd like to welcome to the show Brian Ensign with Superior Essex. Brian is an RCDD, NTS, OSP, RTPM, CSI, and probably has some more acronyms that he can share with us. He is Vice President of Marketing at Superior Essex Communications. Welcome, Brian.
Thank you, Steve. Glad to be on today with you. Really appreciate that.
Great. So we've done some things together in the past. We presented together over in Dubai. We talked about smart building infrastructure and not just powering the buildings, but doing it in an ecological manner. I noticed the sign behind you talks about zero waste. So did you want to touch on that a little bit? I know it's not the topic of today, but certainly it's important to bring up.
Sure. I mean, as we talk about smart buildings and energy efficiency, carbon neutrality, and there's a lot of sustainability initiatives today that a lot of companies have, right? You even see Amazon commercials or any of those big tech commercials have it too. So we're proud at Essex. Our facility in Hoisington, Kansas is 8 years in a row now of zero waste to landfill. So nothing that goes to landfill, it's all reused, recycled, reclaimed. Everybody's very proud of that there. So, and not only having products that commit to sustainability, we operate that way too. So
that's fantastic. That's a really great achievement because really, regardless of which side of the equation you weigh in on the global climate, it's always important to be good stewards of the planet, right?
So, a lot more discussions around that today, and what are we leaving in the world today, right, for our kids and beyond, and what impact can we have? So
exactly,
yeah,
great. Well, thanks for elaborating. So PowerWise. We're going to talk about PowerWise today. What have you got to share with us?
We're pretty proud of that. It's going on over 6 years now of PowerWise. You think back to some of the PoE movements, and when PoE really went to a 60-watt version, some more discussions, and that's where PowerWise is actually came from, is those discussions, right? The power is getting higher. How do we handle it? How do we efficiently handle it? And how do we do it safely? So yeah, for us, that's where PowerWise, going from we used to 5E, 6, 6A, right? So we had PowerWise now as a 1G and 10G for 1 gigabit and 10 gigabit versions. And the difference really is a 22 gauge conductor to be more optimized for PoE, because, we all love dBs and headroom, and it's important to consider the power headroom just as it is a data headroom. So that's where PowerWise came from and started as a whole new line. And our director of product management, Amir Sekavat, came up with the idea, working through the concept with the PoE switch manufacturers. And here we are with PowerWise, and the application for that is really relevant today.
Excellent. And I know you mentioned you've got a 1G version and a 10G version. And I believe we actually ran some tests on the 1G version, and we could run 2G, 2.5 gig on that. So just so people understand, just because the name of the product has that 1G in it doesn't mean you're limited to 1 gig, correct?
Right. It's optimized for that, made for that. But saying you tested it, we're doing some testing with UL at 2.5 to 5 gig, right, and everything in between up to the 10 gig. Right. So yeah, that way any application it's gonna work.
Right. Gotcha. And a lot of that, with that, and of course with the PoE, you're going beyond the normal distances, beyond what the standards specify at 100 meters. So you're going beyond those limits with both of these versions, correct?
Yeah, we innovation, right? Standards. We love standards. We all live and abide by them. We all invest in them. We have input into them, all of us in the industry. But innovation comes from beyond the standard. That's how 60-watt PoE came about. Is the innovation came in the industry, and then the standards followed along with that. But yeah, going extended distances is something that I've been seeing for I guess I'm 29 years in the industry now, going on 30. That's crazy, but it's something people have had, but it's been outside the standards, right? 90 meters horizontal, 100 meters channel. We've lived with it, loved it. But now there's more applications where, hey, I need to run 3 or 4 or 5 drops 110 meters, 120, whatever, because I got to run a camera or something, right? So that's coming up more and more. And with the evolution of PoE and the products to support that, specifically for us, PowerWise, and the 22 gauge, we're able to do that now. And the testing's caught up, the applications are there, the products are there, and we're more efficient. So it's possible today. 5-10 years ago, it was tougher. But
Right.
now it's a reality.
Right. And that you mentioned that 22 gauge, and that makes a big difference, for the data transmission, of course. You've got lower resistance.
Yep.
So that helps you get better performance. So the whole idea behind the 100 meters, and you know this, you've been in the industry as long as I have, is that if you go beyond that on a normal, what we consider UTP, what we used to call type 3 cable,
Yeah.
you start to get collisions on the network. But if you have better performing cable, a heavier gauge, lower resistance, you can probably stretch that out a little bit. And I can see that's what you're doing. And it also applies when we talk about PoE, because resistance is our enemy with PoE. If you've,
Right.
there's a formula out there, and we won't get too technical on this, but I squared R, you take the current squared times the resistance, and that's your loss over the cable. So the higher that resistance number is, the more loss you're going to have. So with that lower resistance, you're able to deliver more power at that endpoint.
Yeah, especially going longer distances, right? Yeah, you have so much power to work with, and you need X amount of power at the end, and everything in between you can't eat up too much of it, right? So yeah, the more surface there in that copper, the better it's going to be.
Exactly. And I've had questions come up before doing webinars, and people have asked, if I'm doing PoE, what's better, 24 gauge or a 23 gauge? And every time I'm going to tell them a 23 gauge. And this is even better. You got a 22 gauge, you've got even lower resistance. So, definitely worth looking at something like this.
And performance too. Actually, the bigger the gauge, the more copper surface area and density you have, actually helps with the dBs, right? The data, the headroom you're going to have on the data side. So it's nice benefit there too. So
yeah, and it's all about headroom. And I had a session with Chuck Bowser a while back, and we compared some tests, and we talked about headroom when comparing big box store cables versus brand name manufacturers such as yourself. And the tests were eye-opening, because you could see, while some of the stuff from the big box might have passed, it was a very slim margin. And we explained that headroom is important, because as it's installed, it passed. That's all fine and well. But if you don't have a lot of headroom, and you start to get noise in the environment as other things come in and are installed, now that headroom, that extra headroom on a quality cable, is going to make the difference between your network functioning or not functioning.
Yeah, very true. Especially if you're going like extended distance, because you're eating into the headroom the longer you go. So if you have the headroom there to be able to absorb that, that's even better, right? And you're going to get that. So at the end, you still see a gigabit signal, and you still see the power you need. If you didn't have the headroom, it wouldn't go much past that 100 meters.
Right. All. Right. Exactly.
Yeah, that helps immensely.
So what else can you tell us about PowerWise?
Well, as you mentioned, the extended distance is something that we've really been working on as of recent, because we're getting a lot of requests and people doing different things. And, the benefits of not needing a IDF or to run 3 or 4 cables out of at a certain point, having that infrastructure to support it, just being able to do it through the structured cabling is a big thing. And so as you start thinking about that extended distancing applications, whether it's a camera or whether it's an access point or whether it's sensing, right? In smart buildings, there's a lot of sensing going on, sensors, and whether it's occupancy or well-being in a space, or oxygen levels, or particulates, or any of those things. There's a lot of applications, and it might be a small percentage of the overall build, but they're there. So it all really comes back to the application. So we're seeing a lot more of that. You think of getting into some hospitality environments, you get into some stadium environments, some of those, seeing a lot more of it. So, we started a project to really look at that extended distance. And actually, if you can show the little slide here, we'll hit that distance here now. And you start thinking about those distances, and it guarantees that happen. This is what we've done. So it's really based on the data, right? Your gigabit, megabit, gigabit, 10 gigabit, and also the PoE type, which is across the top, which is your type 1 through 4, right? A quick review: type 1 being 15 watts, type 2 being 30 watts of power, 3 being 60 watts, and 4 being 90 watts, just as you round this up from the sourcing side. Now you factor in the length, and you're going to have some power, the power that you're going to need for your devices. Example: 90 watt Type 4, running 100 meters. We're going to be guaranteeing, or the standards guarantee up to, I think, between 72 to 75 watts. So that way your devices know you have that to work with. So depending on your data and power, guaranteeing these lengths, and we're able to do that through testing with UL, looking at some temperature testing, bundle testing, worst case environments using live data, bit error rate testing to show it's going to transmit all the data. So send to receive, you're getting all the data. There's no retransmissions, no bits are lost or left on the side. You know, they all made it to the end along that path. So really looking at it from that angle and being able to go that extended distance. And again, UL did all the testing for us, so third party, and we continue to do some new stuff with them. But you start to guarantee any application out to, for example, 1 gig, Type 1, Type 2, 160 meters. And you notice as you go higher power, some of those change, but you get the different lengths based on the applications. So this is really the big focus we're looking at PowerWise today because of that 22 gauge.
Great. Yeah. And I know we've run some tests on your cables. We ran one at Bixie. I think Jacqueline's got that teed up, but we can show that video real quick. We just ran a cable test on it using the custom limits for PowerWise. And if Jacqueline can pull that one up, we'll show that briefly, and then we'll. So I've got it set up for running the PowerWise test limit that we put in here. So what I'm going to do is I'm going to connect. I've got my main connected. I'm going to plug in my remote to the link, and we immediately get a wire map. So that's one of the unique features here. So you get a wire map on both ends. So both techs know right away if there's a wire map problem, you got to fix it. So now we'll go ahead and run an auto test. And since we've already got our limit, now I left the default cable as 6A. I didn't change any of the cabling type, but I've got the test limit in there, which is the important part. So we can see our test summary. We can see that we've got a 141 meter piece of cable here. It passed. We can see the delay, the DC resistance, crosstalk. We can go into details here. So if we wanted to look at any of the details and the network compliance, we can look in there. Get up to 2.5 gig. We can see DC resistance. We can go in and look at, say, crosstalk. If we want to look at that, we can see we've got plenty of headroom on crosstalk. Let's say they did have an issue with crosstalk, though. Technicians can scroll down here to our next locator, and we can look at crosstalk. Now, this looks bad because it's a very short scale here. It's not out of tolerance. So everything is within range here. But if you had an issue where you had crosstalk at one end or the other, either tech could pull it. They could pull it to the remote end and look at it from there, so they know which jack did I terminate incorrectly. So, and then we can see our return loss graph. So a little bit of a spike at the far end. And then we just save the auto test. And then it becomes part of their record, and they can generate PDF reports like the one you see on the screen here. And so, or you can drill in with the software like I've done here. I've drilled into the crosstalk plot, and then I've put a marker on here. So where my worst case was, I put the marker there so you can actually see what's going on with it. All right. Yeah, so that was just a quick physical cable test we ran at the Bixie show. And I visited your labs up in Georgia a couple months back, and we actually ran multi-gig tests. We have that multi-gig SNR testing capability as well as PoE. And we ran multi-gig tests, and we had lengths, 120, 140 meters that were running multi-gig with no problem at all. So it's really interesting to see the performance of this. We know we've exceeded the limits set by the standards, but the cables are performing as advertised.
And you're testing to assure that. And it's nice to be able to match the data up like we get in a nice pristine environment, whether it's in our lab or UL's, to an actual field test. I mean, it's nice to be able to duplicate that and see the same results.
Yep, absolutely.
And it was nice to see everybody at Bixie and being able to do that stuff, get out face to face, and be able to do some testing.
Yeah. So we see the proliferation of the Internet of Things now. So we've got everything is going PoE. We're running window coverings in hotel rooms and office buildings. Monitors that are in conference rooms are powered by PoE. Phones, of course, we've had PoE phones for a long time now.
Right.
PoE lighting, all of these things, and it used to be PoE lighting. They would deliver the power via regular means, the main power, to the fixture and then convert it. But now it's all going over the low voltage cabling. So we're seeing a lot more of our low voltage cabling installers providing this type of installation. So no longer do you have to have that electrician. Of course, that depends on your part of the country, because some areas will say that regardless of the cable, it's got to be an electrician. But we're seeing more low voltage installers pulling this cabling in. So are you starting to see an increase in demand for cables supporting those type of things?
Yeah, for sure. And it's been gaining a lot of traction over the years. What's that outlet doing? Traditionally, your point is data and phones, VoIP or otherwise, or maybe a printer, but even that's network now, to being more of a network that's used for IoT or, now the operational side, IoT, instead of IT, it's OT, the operational technology transformation side of it. So it's used for many things. It's just amazing the amount of devices that are going in that direction, right? If you think about it, it's DC power, which PoE is, and it's data to do control or gather data. It's too much sun's coming in the room, it automatically triggers the shades to come down, right? So you set those parameters, you tell it the rules, and the system will take action based on the data inputs and the data and putting data back out. So Ethernet is great for that. And then it's just DC. So you start to think about DC power, and now we have 90 watts to work with, and you can do more with it. You start thinking, wow, I can do so many things, even ceiling fans to, the USB-C for charging, smart meters. I mean, some of the things may have Ethernet or may not need Ethernet, but they can use the power side of it to be able to do some, powering some devices up. So it has come a long ways, and it's going even further, I think. Now there's talk of DC microgrids. So a PowerWise type cable with a big gauge on it is going to help with that. So now your whole thinking is DC based. If I don't need to convert AC to DC, I'm going to save that energy efficiency, right? Because that's where you lose a ton of energy. And I've seen some numbers up to 20% savings. And if you go full DC grid, 45% savings in energy. So that's the name of the game, is how can it be more energy efficient? And using strategies of PoE, there's new fault managed power now coming through the National Electrical Code. If that gets approved, it'd be a class 4. So there's different mechanisms and means to transmit this power, and it's DC based is the name of the game for sure. So that's picking up a huge traction and a lot going on out there for that.
Interesting. So fault managed power, to me, that says if you had a cable that developed a short for some reason, it would interrupt the power flow. Is that correct?
Yes. So it's communication, it's handshake, right? It's transmit receiver. So it's just things that we're used to. And it's going to transmit that power. It's frequency based power packets, right? If you think of it like that versus AC and DC. And then if there's any type, and it's in the millisecond range, which is way below the threshold of getting any shock or things like that. So, UL is working through all those standards now to make sure it's safe. But all indications are, it's been proven it works, and it's a handshake. So and I've seen some things out there, some videos that some folks have put out where you stick your finger in the socket and you don't get shocked, right?
Wow.
So who's brave to do that, but make sure it's connected.
Yeah, I've got stories of things like that when I was a child. So
wasn't that the 9-volt battery? I don't know if there's a 9-volt battery or a socket. But
yeah. Interesting.
It's like that.
Interesting. Wow.
Yeah, it's a big movement. But along in your side, though, I mean, I'm curious too, do you see a lot more people talking about that from the testing side? I know extended distance. I know you have all the tests loaded in for that, but is that conversation happening also on your side of the business on the testing certification?
It is. We're starting to get more questions about extended distance cables and being able to run power at greater lengths. Why? And one of the big things we get, because we do the PoE load testing, is why is my PoE not working? Why am I losing power? And of course, a lot of it comes back to the things we talked about. The resistance is the enemy. And people, they think about the cable they install. So they ask the question, Joe, should I go 24 or 23 or now 22
Right.
with PowerWise? But things that they don't think about when they're considering all this is things like the patch cords or the
Good
jacks
point.
that you're using to terminate. If your jacks aren't optimized for the cable that you're installing, you can introduce issues there too. But the patch cords, I've been on job sites where people replaced a patch cord. They lost one, doing a move or something, and just put a cheap patch cord in place. And it was a short PoE run. So, the PoE run was something on the order of, I don't know, 30 feet. It wasn't very long, but the patch cord was 10 feet. Now your patch cord is 25% of your overall budget, and they were having a resistance issue, and it turned out to be the patch cord.
Especially the
So,
28 gauge patch cords, right? I mean, that's going to
yeah,
see that power.
it can be this, the smaller gauge, you're going to lose the power, a lower quality where they don't pay attention to resistance unbalance. So that's a big one.
Yep.
Not just is it the loop resistance we have to be concerned with, it's the DC resistance unbalance. So if there's too much difference in the resistance values between each of the pairs or within the pair itself between the two conductors, that can create problems for PoE where the electronics start to suffer problems because of the difference in resistance. And the devices, the PoE devices have the PSEs have problems providing the power to the endpoint because of that resistance unbalance. So those are all part of the tests that we do when we run a physical cable test. And then, of course, beyond that, once you get your PoE equipment up and running, we do the PoE load testing. So the user can go on and actually put a load on it like the tester is a powered device and see if I can actually get that power at the endpoint. And we took it a step further. We've got an adapter that we do the PoE load testing with. It has banana jacks on the adapter in addition to the RJ45 jacks. And with those banana jacks, you can attach an external load box, set a load in 15-watt increments all the way up to 90 watts. So you can determine what load you want to put on it and let it sit over time. It'll monitor the SNR of the Ethernet connection and the PoE over time and build a CSV file. So if you've got a piece of cable, you want to see how it'll perform over several hours under a constant PoE load, you could do that. So there's all kinds of things that you can do to test your infrastructure to see, is it going to do what I need it to do once I start hooking up all my stuff?
And avoid any issues, right? And that's what you just mentioned, physical and length. You start looking at that. I mean, electrical length is going to be different than physical, right? Because of the twists in the cable, and depending on what cable it is, what grade it is. A Cat 6A cable have more twists than a Cat 5E cable. That's just a fact, right? So that's going to electrically be longer than you're physically showing. So the field testing, it shows you it's electrically, that's the game.
Correct.
Physically, it might be a little shorter, but electrically it could be a little longer because there's more copper.
And it's funny because you'll get that question where somebody looks at the footage markings on a piece of cable and they go, I know that my cable is not this long. Your tester's showing that it's this long. What's going on here? And then they get the question, why is each pair show different? I must have a problem with my cable. And then you have to go into the explanation. Well, that's for performance. Each pair is going to be a little different to mitigate crosstalk. And so it's constant education in our industry, not just for the people that are out there installing your cable or using our testers, but for us too. Every time I do one of these, I learn something from questions that we get. Anytime I attend a Bixie conference, I learn something. And that's the name of the game. This industry, things are changing so rapidly that we have to stay on top of it as professionals in this industry. And we have to be continually learning. Otherwise, we're going to be left in the dust, right?
Yeah, you look at Bixie this last time, it was over half, just off the top of my head, over half the presentations were about smart spaces or smart buildings, smart cities, any of that, or PoE, right? So it's that next evolution of technology into the future, for sure. The other thought I have is really thinking about future proofing, right? Because what we know of today for the applications could continue to evolve. So look 3 or 4 or 5, 10 years from now, I mean, this could really be doing a lot of PoE and smart buildings and grids, cities, all those applications, right?
Yeah.
Driving cars. I mean, that's all going there. So How do we
Oh yeah.
future proof for that? And we do have some that, you take the 10 gig version of PowerWise versus a 1 gig. 10 gig, you can do more with it. I can handle the same 90 watts of power. It's gauge, 22 gauge, but data, I can do more with it. So we do have some customers that it's 10 gig, 22 gauge PowerWise every outlet. Doesn't matter if it's 10 feet out to, 160 meters, right? So that way as we know what we know today, they can handle any application.
That's some serious future proofing. So
Yeah, down the road.
there were a couple questions I had here. Two things. You're guaranteeing up to 160 meters, and how's that possible? But the other one, is there a standard that can be referenced for these applications?
There isn't. Well, we all focus on TIA, right? TIA being our requirements and what we manufacture cable to, and performance, and all those things. VIXI for your best practices, right? So we use those a lot. The whole industry does. But there is specifically to extended distance. No, there's nothing in any accredited standards base that you can reference. Hey, if I use this grade of cable, I'm going to be guaranteeing this distance. Everything's still 100 meters. All the switches, IEEE is basing, whether you're Cisco or any switch manufacturer, it's all based on max 100 meters. And that's how they size their power supplies and the sources and their switches to be able to handle Ethernet and PoE. The further you go, they might have to bump up some of those power supplies, right, to give more power. But I think this will drive standards development. I think this will drive, just like direct attach or direct connect applications. You think back a few years, just like PoE going to 60 watts from 30 watts. I mean, the industry innovation and movement is going to drive the standards development to be able to handle, how do we document what's worst case for beyond 100 meters? And we started that process ourselves with UL to go through that process with them to go get a program together that's specific to us, but could drive some different standards development down the road to how do we handle it? Fault managed power. That's something that's in our world and in our application today, and it's just going through the NEC now, but it's been available for 3 or 4 years. So it's the same type of scenario. So today, no, there isn't. So it's up to us as a manufacturer to stand behind it and warranty it with our documentation. So, based on what I showed earlier, that's what our contractors and designers, consultants can use. And then we stand behind that with a warranty, lifetime warranty to be able to support those applications. And so that's a documentation that goes with it today. And as certified through your tester, right? Your field tester units. Yep. And that's the proof at the end of the day that it's going to support the warranties and close that loop, and everybody's protected. So that's how it's being done today.
That's great. That's great. That gives the end users an assurance, that it gives the installers an insurance too. They go to, it's their reputation when they go in and sell a project to an end user. They're pitching your cable, and you're backing it, and then it gives that end user that they're installing it for that feeling of confidence that yes, I'm ready for whatever that next big thing is coming. And you're right, what the applications that are developing, the new technologies that come out, those drive our standards. I mean, I come from a time when we didn't use twisted pair for Ethernet. We used coax for Ethernet, and coax the size of your thumb, and you'd put a tap on it, and so we go beyond that, and everything, all these various network topologies started migrating to twisted pair, and that's what drove our standards for twisted pair, and it was so we could have a standardized cabling system, and everything seems to keep driving this way. As these technologies come out, they're driving it to either run over this twisted pair or they're going to run over fiber. Those are going to be your two choices. And we're doing so much more with twisted pair now than we did back in the 90s. I mean, I thought we were hot stuff when we had 10 meg to the desktop. And now look at us. If you don't have a gig switch in your house, you're probably living under a rock. So it's
what's going on, right? And PoE forever. High powered 90 watt PoE is kept. His copper is still alive.
Yep.
Because of those applications, for sure.
Yep. Well, great. Well, it looks like don't see any other questions in here. So it looks like we're right at the bottom of our half hour. Okay. So before we close out, I just want to thank you, Brian, for joining us today. It's been very insightful. The more I learn about PowerWise, the more excited I am about how it's going to be applied in the field, and how contractors can assure their customers of delivering the power and delivering the data, going beyond that typical length for those situations. And I do want to mention that we are going to be at Cablex in Egypt the end of March. So just in case anybody is looking at going to that show, you can come by and see Superior Essex and AEM. We'll both be at that show. And with that, Brian, thank you very much for joining us.
Yeah, no, appreciate that. And it's always great to hang with you and see you. And it's good to spend time.
All right, great. Well, thank you, everybody. And we'll see you back here on Tech Talk with Steve in a couple of weeks.
Thanks, everyone.